JavaScript is a dynamically typed language, which means you don't have to specify data types when declaring variables. It has a rich type system that includes both primitive and reference types. Let's explore how data types form the foundation of JavaScript programming. There are primarily two types of data types. Primitive types such as numbers, strings, booleans, undefined, null, and symbols. And reference types such as objects, arrays, and functions. We will also explore type coercion, in which JavaScript automatically converts types, which is very important to understand. Let's delve into the primitive data types in JavaScript. First is the number type, which represents both integer and floating point numbers. For example, let age equals 25, let price equals 99.99, let infinity equal infinity, and let not a number equal nan. Then we have strings, which are sequences of characters. For example, let name equal John, let greeting equal hello, and let template equal value : space and then the value of age, which is 25. Next we have booleans, which are logical true or false values. For example, let is active equals true, and let is logged in equals false. Then there is undefined, which is automatically assigned to uninitialized variables. For example, if we declare a variable called username without assigning a value to it, it becomes undefined. Next is the null type, which represents the intentional absence of any object value. For example, let user equal null and let data equal null. Finally, we have symbols, which are unique and immutable primitive values. For example, let ID equal symbol of ID, and let key equal symbol.for of key. BigInt is another primitive type in JavaScript used for working with arbitrary precision integers. It allows you to safely store and operate on large integers beyond the number type's safe integer limit. Regular numbers in JavaScript are limited to plus or minus 2 to the power of 53 minus 1. To create BigInt values, use in at the end of a number, or use BigInt function. For example, the maximum safe integer in JavaScript is 9,7,199,254,740,991. This is represented by number.maxSafeInteger. Let the BigInt value equal 9,7,199,254,740,991 and let another BigInt equal the BigInt function with the same number within a string. Now let's see how to work with BigInt. For arithmetic operations, remember to use n after all numbers. Let a equals 2n and b equals 3n, then a plus b equals 5n, a times b equals 6n, and b divided by a equals 1n. Note that it will be truncated and not 1.5n. For comparison, 2n is greater than 1n, which is true. 2n is equal to 2, which is true, however 2n is strictly equal to 2, which is false. Also note that you cannot mix BigInt with regular numbers in arithmetic operations. To check the type of a value, typeof 42n gives BigInt, 42n instance of BigInt is false, but the object of 42n is an instance of BigInt is true. Now let's explore reference types in JavaScript. These are objects, arrays, and functions. First, let's look at objects. Objects store collections of key-value pairs and are passed by reference. For example, let person equal an object that has name as John, age as 30, and a greet function that returns a string saying hello and the name of the person. There are many built-in methods for objects such as object.keys, object.values, and object.entries. Next we have arrays. Arrays are special objects for ordered collections. For example, let fruits equals an array containing apple and banana. You can add more items to an array by using the push method. There are many built-in array methods like map, filter, and reduce. Finally, there are functions. Functions are first-class objects in JavaScript. For example, here we have a function declaration of multiply that takes two parameters and returns their product, and an arrow function that takes two parameters and returns their sum. Functions also have properties like toString or length that can be accessed. Reference type variables store a reference to the object's location in memory. This means that multiple variables can refer to the same object, and changes made through one variable will affect all other references to that object. The variable is stored in memory and it holds the reference to the object, which is stored separately in the heap memory. Type coercion in JavaScript refers to the automatic conversion of values from one data type to another when operators are used with different types. This can lead to unexpected behavior, so understanding how it works is important. There are two types of coercion: implicit type coercion and explicit type conversion. With implicit type coercion, JavaScript automatically converts types. For example, if you have a string with the value 5 and you add the number 3, it becomes a string concatenation and you get the result 53. When you subtract, the string 5 becomes a number, and the subtraction occurs giving a result of 2. When you add true and 1, the Boolean value is converted to number resulting in 2, and if you add null and 1, the null is converted to 0 resulting in 1. For arrays, when you add array of 1 and array of 2, they are converted to string, which results in the string 1, 2. Explicit type conversion is done by the programmer using methods. For example, you can convert a string to a number by using the number method, the parseInt method, or the parsefloat method. Similarly, you can convert a number to a string by using the string method or the toString method. You can convert a value to Boolean using the Boolean method. When we convert undefined to a number, we get not a number, null becomes 0, true becomes 1, and false becomes 0. So, it is better to use explicit conversion for clearer and more predictable code. Here's a table that shows the values after explicit conversion. When undefined is converted to string, it becomes the string undefined, number gives nan and Boolean gives false. When null is converted to string, it becomes the string null, the number becomes 0 and the Boolean becomes false. When the Boolean true is converted to string, it becomes the string true, the number becomes 1 and the Boolean is true. The typeof operator is used to determine the data type of a value. It returns a string indicating the type of the operand. When you use it with numbers, it gives number. With string, it gives string. With Boolean, it gives Boolean. With undefined, it gives undefined. With null, it gives object. This is a well-known anomaly. With objects, it gives object. With arrays, it also gives object. With functions, it gives function. With BigInt, it gives BigInt, and with symbols, it gives symbol. Now let's look at common gotchas. The typeof null is object, which is a known bug in JavaScript. Arrays are also considered to be objects, and to check for array we have to use array.isArray method. Here is an example of safe type checking. If we have a value and it's null, then return the string null. If the value is an array, return the string array, otherwise return the typeof value. The instanceof operator checks if an object's prototype chain includes the constructor's prototype. It is primarily used to determine if an object is of a particular class. For example, if we create an array, it is an instance of an array and also an instance of an object. If we create an animal class and a dog class that extends the animal class and create a new object using dog, then that object is an instance of dog, animal, and object. The prototype chain is shown here. The dog object has access to methods and properties from the dog prototype, which has access to methods and properties from the animal prototype, which has access to methods and properties from object prototype. Here are some common patterns using instanceof. An empty array is an instance of array which is true. An empty object is instance of object which is true. An empty function is instance of function which is also true. However, string, which is a primitive type, is not an instance of string. If you create string using newString, then it becomes an instance of string. There are some issues with cross-frame instances as well. So be cautious when using instanceof with primitive values or cross-frame objects. Now let's understand the differences between null and undefined. Undefined is a primitive data type, and when you use typeof operator with undefined, it gives the string undefined. While null is also primitive data type, but when you use the typeof operator, it gives the string object. Undefined is the default value for variables that have not been initialized with a value, while null must be explicitly assigned to a variable. When a function doesn't return a value, it will return undefined. Null is never returned automatically by functions. Undefined is a property of the window or global object, but null is not a property of any object. When you use equality comparison with null and undefined, it is true. However, if you use strict equality comparison, then it's false. If you declare a variable without initializing a value, it's undefined. But you can explicitly assign null to a variable. Here is a table of when to use undefined and when to use null. Undefined is used for default parameter values in a function, and to check property existence in an object. Null is used for intentional absence of values, like when a user is not available yet, or to clear a cache object. Here are some recommended practices. Use undefined for unintentional absence of values, and null for the intentional absence. Always prefer strict equality when comparing with null or undefined, and consider using optional chaining when accessing nested properties. Now let's go over the best practices for type checking in JavaScript. It's a good idea to create type guard functions that check if a value is of a particular type and returns true or false. We can also implement robust value checking, especially when dealing with JSON responses or validating array types. Also, it's recommended to always use strict equality with triple equal operator when comparing types and values. Here are some advanced type checking utilities that can be used. The type checker object has methods for checking for different types of values. For example, isNull method checks if the given value is null. Similarly, we have isUndefined, isNumber, isInteger, isFunction, and isPrimitive. Avoid relying on constructor names for type checking as they can be changed. Here is an example of duck typing pattern. Duck typing is a concept where you focus more on the abilities of an object rather than the actual type of the object. To use duck typing, you check if the object has specific properties or methods that are needed to perform the required task. This can be useful when you don't want to be tied to specific class hierarchy, but rather focusing on how the object can interact. Here is the implementation of the isValidUser function that checks if an object has the properties ID, name, and the function login. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.